Hey everybody, this is Larry. This is day 7 of the November Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's poem, if it ever wants to load. We have a hard one today, not much happened today. I'm still resting. I mean, actually, I went to the gym, did some upper body stuff, but just resting. Still feels tired, even though I seem to have slept okay, but it's just one of those things, I suppose. But yeah, without further ado, today, let's do today's poem. We have 2528, a hard one. Maximize the minimum powered city. Okay, so you're given stations in an array length n, where station sub I is the number of power stations in I city. Okay. Each power station can provide power to every city in a fixed range. Okay. If the range is denoted by R, then a power station that I can go to R in a... Okay, so it's just like whatever, right? Okay, absolute value. Okay, we know what absolute value is. The power of the city is the total number of power station it is being provided power from. Okay, the government also has sanctioned, I can't read today, sorry friends. The government has sanctioned building K more power stations, each of which can be built in any city and have the same range as the pre-existing ones. Given 2 integer R and K, return the maximum possible minimum power of a city if an additional power station are built optimally. Note that you can build K power stations in multiple cities. Okay, I think I kind of get the idea, but for better visualization, let's take a look at an example. Oh man, looks like this power station is getting sneezed out. Okay, I mean, I think just to be just a little bit of a spoiler, if you will, my first instinct is going to be binary search. But let's actually read example 1 so that we actually understand it, right? Okay, so we have stations. We have K is equal to 2, so I have to install 2 somewhere. We want to say 0. City 0 is going to be 1 plus 4. Oh no, it's 1 plus this, which is now a 4. And then the second one is this 3. So okay, so then the idea here is that okay, you have some sliding window. You have I mean, you don't even have to do sliding window per se. You can do it with a prefix sum or something. But yeah, but sliding window is fine. I would say prefix sum you still can do it with this K, but it's just a little bit like you have to be careful, right? But yeah, okay. But yeah, it seems like it's just binary search. The reason being that it feels like it's binary search is because then now, if you look at kind of this example, right? If you look at this input rather, on example 1, and let's say you binary search and you go, okay, let's say here's 5, right? Well, if you have this, then now you're forced to add, you know that you can get to 5 in a greedy way, right? Because then now you just add 2 to one of them, and of course, in a greedy way, if you have to add, the first window, you have 1 and 2, and you have to add K power station somewhere, then of course you add it to the rightmost one because, well, yeah, rightmost one because that has the most impact of stuff that includes this one, right? So I think that's basically it. So yeah, I don't know. Today, I don't know. Today I'm just feeling a bit lethargic, a little bit tired. I think also like today it's like really cold here in New York City. In fact, I almost wish that this was or this temperature is the marathon temperature, because during the marathon it was a little bit too hot. It is what it is. Everything reminds me of the marathon, but in any case, but I'm saying that in the context of I think I was walking outside trying to like get some active recovery. I walked like about 5 to 6 miles today, and I think maybe it was a little bit cold, so I think like my energy is like a little bit sapped from that. So my apologies. Why I'm saying that is because maybe my explanation is not quite crisp or as detailed as it would like. So okay, so maybe we'll go over the code after I implement it. Maybe that'll be better. But okay, so we have a right, and then power. So this is just binary search setup. Each station can be 10 to the 5th. K could be 10 to the 9, or it could be also another 10 to the 5th. So that means that the sum of everything is at most, or at least, or the highest thing is going to be 10 to the 9 times 10 to the 5th, which is just the sum of every power station. So it's going to be 10 to the 14. For fun, we'll just do 10 to the 15 because, you know. And this is regular binary search. I don't know if I'm doing anything funky about it yet, right? So then now we have a good function. So if the current target mid is good, that means that we can try a smaller. No, that means that we could try a bigger number, right? So then we just set left is equal to mid, else right is equal to mid minus 1, and we are Gucci, right? And now we just have to implement target. Yeah, as we said, we're going to do sliding window. We have to be a little bit careful in terms of how we handle K, right? But that's fine. We just, in terms of like if you add it and knowing where to subtract from it, etc. Right? There are probably a couple of ways you can do it. We'll just use a Q, I think. Right? Yeah. So okay. So then initially, oh wait, is K the? Oh no, R is the radius. That's what I was thinking of. And R is at least 1, right? Oh no, R could be 0. Okay. So that means that we want to sum from let's say we're at I. At I, sum from I minus R to I plus R, right? Inclusive, obviously. So we have to get the initial one, which I always don't know quite how to write it, but maybe it's fine, right? So maybe we could just say initially. So I is going to be from I to I plus R inclusive, right? So this, right? Because if R is 0, then it's just I. Oh, sorry. Well, I is 0, right? For the first one, so this is going to be good, right? Yeah. So the first one, this is going to be first one, right? Maybe I'll even just call it current. Okay. Then now we start from I in range from 1. What? How did that all get there? All the way to the end, right? Oh yeah. So then now we want to say, well, this is for the initial kickoff, right? So if current is less than target, we have to build some power plants, right? And we will build it at and maybe I'll write needed, right? Is it how many things we built? So then needed, we add target minus, oh, the other way around. No. Oh no, yeah, no. So then we built, that's how many we built. Left, we oh, I guess I did left, so I guess I don't need, okay, whatever. This is fine. Let's just say needed, right? And once we built, we want to put in like K dot up. I just want to put in the index, which is going to be at R, right? Because I plus R is 0 plus R, which is R. And basically what I'm saying is that if we build it at R, then that's just how we're marking it, right? So then when this index becomes our bounds of the sliding window, then we'll get rid of it. And then we'll just also put target. Maybe that's a little bit redundant or whatever, right? Okay. So then now we want to put I plus R into the window, right? Yeah. So then current, we add from stations of I plus R, assuming that this is, less than n, right? Is that it for the right side? I think so. Yeah, because then now we have to take I minus R outside, right? And yeah, and then this is just But of course, you also want to make sure that you removed whatever's on Q, right? So if length of Q is greater than 0 and Q of 0, if the index, which is what we care about, is equal to I minus R, then now we also, pop left. So we have the index and then the D for delta current, right? And then now we do the same thing as before. So if target is greater than current, we add target minus current. And then in this case, it's going to be I plus R, because we're putting, if we need more, we're going to put it as I plus R because that's just the most to the right, right? And that should be good. And even if this is out of bounds, it's actually kind of okay because you get rid of it on the last one anyway. It just means it's the last one. So yeah. Okay. So then now if we just return whether needed is less than or equal to K, because we can only do up to K. And that should be good. Maybe, probably, close to it. Maybe not. Why do I think it's 2? I mean, it's definitely not 2. And why is this default thing? Okay, maybe that's not a good default. I don't know. I'm so tired. I don't know why I'm so tired. But this looks pretty straightforward, so I don't know. Okay, let's just. Oh, I see. The reason is just because I added this to needed, but then I do not add it to technically I write this, which makes it target, but I think that this is okay, let's just write add. That's A for add is equal to target minus current, right? Needed, add that. Current, we add it, so technically that makes it whatever, right? But then now we also need to do the same thing here. And you could probably use the helper or something. Okay. Because if I don't do that, then it keeps on adding it, and that's why I think it's giving me issues. A very silly mistake. Okay, I mean, maybe there's another mistake, but that's at least definitely a mistake. Oh no, this is right. Why is it not working? Okay, fine. Okay, so maybe we print target. Let's just start with the basics. Needed and K, right? All right. Well, is my internet up or is it just Leetcode? No, but it works fine. I mean, even this loads, so I don't know. It's telling me to log in. Why would it lock me out while I'm like in the middle of doing this? All right, let me try to log in real quick. That's probably why, like some weird cookie expiration thing or something. I don't know. The code is very weird about it. Maybe people are sharing an account too much or something. I don't know. I feel like I'm logging in every day, and I don't know. Like I'm not trying to. The code is always so dumb. Also, maybe my browser's just messed up. I don't know. Right, it is taking a while. Because maybe my computer is just having issues, honestly. I need to migrate away from Firefox, maybe. Alright, I logged in, so let's see if clicking this. I mean, how does it even happen? We ran examples and then and then like it just logs you out in the middle. It's very weird, but okay. Anyway, now that it's good. Okay, so target doesn't work. Okay, so it's saying that if we have 2, we need to use 2. And that's fine, maybe they're saying. That's probably not right. Am I not adding it right? I don't know anymore. Current is the current. I don't know. Why is current so big? Oh, because you had. Oh yeah. Okay, fine. I guess that maybe makes sense. Okay, so the current is 3, which is actually right for the sliding window. So okay, so no issue there. Okay, let's see. Where is this 6 from? 6 is from. Is that 6? Is that right? Oh, I see. I know I'm doing well. We put I plus R into the window, but we don't take I plus R. It should be I minus R minus 1 because we want it to be inclusive. I am just bad at thinking today. All right, let's see. Hopefully this resolves it. Looks okay. So, well, before I say, sound smart or whatever, or pretend I'm smart, let's give it a submit first. And then if it works, then maybe we'll do it. We'll say, okay. So it really was just a very silly off by 1 on the sliding window. I don't think I gave a great visualization on this one, but yeah, I don't know. Sorry, fans. Wow. Apparently I did this like wrong many times before. Did I just use an algo or something? I was also thinking, oh no, I mean this is probably a similar idea, but I don't know. Maybe just bad implementation then. I didn't get anything wrong today. That's good. I mean, I just got confused because my internet or Firefox or whatever is being weird. But yeah, I think the key thing is to note that, given a target, you can solve it with greedy, and that allows you to do binary search. And you can see, like, I don't know. I mean, I did it with sliding window. You can do it in other ways. Maybe when using a segment tree, if you really like, I don't think it's too slow, but maybe it is though. So don't hold me to that one. Actually, it definitely is too slow. If this takes too long, 4.6 seconds. Why is it so slow? Huh. Oh, I guess that's why I have 2. I didn't even notice this. I mean, I just saw red, but I guess that's why the 2 time limit exceeded once. What did I do last time? This looks pretty straightforward. So I think it's just Leetcode being silly in the past, possibly. I mean, I know that the bounds aren't that tight, but it's still just Leetcode being silly, if you ask me. But yeah, what's the complexity here, right? Well, this is going to be O of, let's just say B, where B is the number of bits, right? Because, just binary search on the answer kind of thing. This is going to be linear time, linear space, due to the queue. I don't know if you could do that much better. I mean, not just complexity wise, but even like micro optimizations. I don't know how it's so fast. I mean, I know that time I did in C++, presumably because it was a contest. I gave up and then tried doing C++, but I actually don't know why it. Like, what can you? What is this one? I did with prefix sum. I don't know that that's slower. I I think the one optimization that you can do, for example, and I don't always do this because it always feels unnecessary, but or like it shouldn't be necessary during a contest, but something that you can do is something like so if you do an early termination, that helps with some complexity. We'll give it a submit just to kind of see how much time it saves, and you can see it, right? Like it saves half the time, but it's just very silly, if you ask me, because it's just, I don't know, it's not that interesting. But yeah, all right, that's all I have for this one. Let me know what you think. Thanks for watching. Hopefully I get enough rest. I think honestly my body is still like recovering from the marathon, and I think maybe I tried to do a little bit too much too early today. But yeah, thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.